Hello, my dear students. Very welcome to the first lecture and introductory lecture on electromagnetics. Here you can see I have give you a reference book, that is Field and Wave Electromagnetics, that is written by David K. Cheng, and in that case we will go throughout this book and understand this, and I will also give you some lecture on electromagnetics, uh, because we know electromagnetics comes from two different words that you have seen, and I will give you some elementary lecture on this. As you can see, the book name is Field and Wave Electromagnetics. That means electromagnetics. There are two forces in our world, that is electric force and a magnetic force. They are known as the fundamental force. Okay, so on this occasion the electric and magnetic force are correlated forces. If there is any electric force, there is also be a magnetic force, and if there is a magnetic force, we can also find out some electric force. Have you got it? And that is the basic physics that we know, and this course has been designed uh, in the sense of the physics. If you have some knowledge about physics, that you can get onto it and understand this. So first of all, we will go through to the first chapter of this book to understand the introductory part of electromagnetics, and also know the introductory and fundamental parts of electromagnetics. Okay, so first of all, we have to know what is the electromagnetic model. Electromagnetics is study of the effects of electric charges at rest and in motion. Here we can see there is a line that's been written here. The study of the effects of electric charges at rest and in motion. Motion means that is continually moving from one side to another, and rest means it's not movable. So here is also the part of the things. From the elementary physics we know there are two kinds of charges, that is positive charge and negative charge. Both positive and negative charges are the source of an electric field. It means it is the source of an electric field. So moving charges produce a current. That is the first thing. If we just think there is a certain kind of a line, and we know if we apply voltage in the two side, we know there is an electric flow that come to this direction, and electricity, we know the conventional direction is the positive to negative. That means the flow of electron gives us the electric field. So moving charges produce a current which gives a rise to a magnetic field. That means this the moving charges give us rise to the magnetic field. How that we can get? As I said you earlier, that you can understand it from the two parts, the two fundamental forces, electric force and magnetic force. So if electric force, that has been denoted here as E vector, is applied to a body, a metallic body or another thing, the magnetic force is orthogonal to it. Orthogonal means that has been perpendicular to each other. That means that is 90 degree to each other. Okay, the magnetic field is also associated with it. How that will be created? The first basic is that if you move an electron around about a spiral phase, so that will produce a magnetic field out of that. And if you give a straight conductor or as iron, cast irons, it will be it will use as a magnet. So there will be a north pole and a south pole will be created. So that's the basic thing that you have to understand first of all. So my dear students, electric field, if you get the electric field, orthogonally you will also have the magnetic field. Now you have a question, very common question, that the some wires carry the currents, that means all fields are carrying magnetic field. So why we not we don't uh, get that the irons and the other magnetic materials are attracted to the wires? The thing is that the field is too low in that sense. That is 90 degree, but it's too low to uh, be a magnet. So if it should be a magnet, so first of all it should have to have gone through the spiral phase. That means uh, the the electron should be moving towards a coil, then you can get the field out of it. Otherwise you can't get it. If it is a straight line, the magnetic field is too much lower. If it is a spiral line, that means it's a movable, there's a moving electron, clockwise direction or anti-clockwise direction. So that's a straight direction. If it is a clockwise or anti-clockwise direction, that means rotation. There's a difference between moving and a rotation. If the electron rotates, it always produces a magnetic field itself. And if you just place a iron core inside, it will act as a magnet. If the current enters through this, that will be a north pole, and current just outreaches, that will be a south pole. So that's the basic thing that you have to know in the electromagnetic model, that how this field creates with each other. So my dear students, we understand these two forces are associated with each other and perpendicular to each other, and from electric field we can also get magnetic field. And how could we get magnetic field to electric field? That is pretty much similar, that if a magnet moves round throughout clockwise or anti-clockwise direction, and if we place here two other metallic cores to take this as we know, the Faraday's law, if the field cuts, it will produce current. As you know, in the previous semesters, Faraday's law, there is a north pole, south pole, there is a field. If the field cuts itself, so it will produce a current. Okay, so movable magnetic field, a rotating magnetic field is not movable, that has to be known as the rotating magnetic field, causes electric field. So vice versa, if electron rotates, that means electric field is rotating, you will get magnetism. If the magnetic field rotating, you will get electric field from out of it. That's the main source of understanding in this part of electromagnetics. So my dear students, I hope you understand the first part of our lecture, the introductory parts, how the electromagnetic fields created to each other and associated to it. Thank you very much for being with me. I will give you some extensive lecture on the next lectures. Thank you very much.